G'day everybody. A few years ago I had an attempt at making a scripting class for tyFlow. I'm going to try and improve on it a bit because, I think it wasn't as good as it could have been. But more importantly, programmers are kind of a group of people on their own. They kind of have programming minds. That doesn't mean artists can't program. It just means it's not as intuitive. So let's try and kind of start somewhere, right? And the first thing we kind of need to know is we have variables, right? And they contain data, some sort of data, position, rotation, a number. And if we kind of just think about it like this, and we drew this box, all right, and we said that, okay, this is our variable, right? So we're going to make that our variable, right? And then we're going to store something in it. So let's say we stored a number 2 in our box. Well, this information that we're storing, that's a variable, has a type. In other words, if a car was in here, the type could be Ford, Jeep, etc. Right? But in this case, the number 2 could be an integer, right? And an integer is a whole number, right? So we don't need to remember all of this, but we do have to at least know 3 types, and then we have to know some tyFlow types. So the variable that we can give a name to, so let's name this a number. Right? So that's our variable. So for example, we're saying that this box is the container, the variable, that's going to hold a whole number, and we can put any whole number into this variable and temporarily store it and refer back and use it. So how do we define such a variable? Well, in C++, which is what tyFlow scripting is based on, we would use a thing called an integer and then the name, and we decided us to call it a number, right? So, and then we need to put this semicolon at the end to define the end of a single line of code. So every single line of code is going to have a semicolon at the end of it, except for functions and things which are too complex right now. Alright, so that was one variable type, an integer, which could only store whole numbers. 1, 2, 3, 10, 100, with no decimal places, right? So let's look at another kind of number. Let's say we want to hold decimal numbers, so we're going to hold 4.1, right? Well, that can be one of 2 types. It can be a float, or it can be a double, alright? Now, what's the difference between those 2 types, float and double? They both hold decimal numbers. Well, the double can hold a bigger decimal number than the float. So, regardless, we could have one of these 2 types for a decimal number, right? So we'll just say in here decimal. And all my terminology here while we're talking about this is not going to be perfect. I'm just trying to break it down into understandable chunks. So I'm not going to be super savant specific, right? So now our variable container is going to contain a decimal number, right? So we still can give it a name, right? And in this here we just put a decimal. Now you'll see that I'm using capitalization to help me. So a small thing, just whatever way you want to do this, and then D for decimal, and you can use this small large letter naming convention to make your variables easy to read and understand later. Right, so in code we would now say, if it's going to be a float, we would now say float a decimal and we've now defined a line of code that tells us we have a new variable that's of type float that we can use in our code. Right? If we wanted to initialize it, we can now, in the next line of code, say a decimal equals 4.1 semicolon. So now we have two lines of code, line 1, line 2. In the first line, we define a variable, which is a container to hold a decimal, and it's of the type float, and we're going to store the number 4.1. Now, there would be no difference in a float or a double as far as what these two lines of code are, except that if it was a double, we would type a double here. Right, so that's kind of an introduction to variables in C++, and it's better to try and understand it in small chunks, especially if you're not a coder. We're going to try not to go deeper than we need to quickly, but there are just some parts of this that we have to go over, and no assumption being made that you got previous coding skills. I have to cover what I think needs to be covered, but here we have a fairly simple tyFlow flow. It's got 3 script operators in it. One where I actually have complete code samples, one where it's the default but it has the commented out help, and this one is just blank. So the way that we add scripting to tyFlow is we add one of these script operators, and the way that we access the code is we click on the operator and then we open the script editor, and now we're looking at the script that's in that code. So first thing we see, and I've deleted the default code, is 4 functions, and we haven't even talked about a function, so let's just quickly talk about that. And we look here, and a function you can think of as a collection of code grouped together, kind of like putting all your groceries in a bag. In this case, the bag would be the function, and to access the groceries in the bag, we would reach into that bag, in this case aka a function, and then we would execute or grab some stuff. So, you know, the way a function is defined is this public means, is it accessible to everybody or not, right? And in this case, we're not going to talk anything outside of public because that is just way too deep. And so in our case, all things are public. And then there's a return type. In other words, in this bag of code, group of code, are we going to return something after we've performed that group of code? And then what is the function name? All right, so this is the return type, and this is the name, and curly brackets here. That's kind of how you define a function, and it could have parameters in here. It could. So you could ask for parameters, and we'll explain that at a later stage. And then we have this opening curly bracket, right? And we have this closing curly bracket. So this whole section here is a function. That is the default formatting for how you create a function, and code goes in between these curly brackets, right? So any code for this function would go in between these curly brackets. Now tyFlow has several of these, but we're only going to be concentrating on the simulating step function, and that is executed every step, every time step, right? So we don't have to worry about the details here because it has no parameters and it returns nothing. So we can put lines of code in here. No, they will be executed every time step, right? So every time step, every frame here, they will be executed. So let's look at the operator itself for a second. So we've got these 3 script operators in this flow. The blank one, the one that's commented and as if you just dropped it in by default, and then a complete working example by me. So how do we access the code? we click on the operator, the script operator in question, and then we open the script editor. It is broken into 3 sections. The code area, which is the black background part. The debugging area, which is this green part. It'll turn red if you have some kind of error in your code. Now let me tell you that coding is very, very specific. There's no making errors. If you type it wrong capitalization, you're going to get an error. Wrong format, you're going to get an error, right? It's a very exact process, but at least this will turn red if there's something wrong, and then hopefully you try to do what we call debugging and find out what's wrong with your code and correct it. Then there's this API button at the bottom, which is like the programming reference guide for what tyFlow allows you to do, or what tyFlow scripting operator supports. It's just a text document, very basic. I'll show you a different way to look at this. I've got Notepad++ where I've got each one of these sections broken into their own grouping, but it uses this commented structure to define a group of properties or functions or variables that you can use in tyFlow, and there's quite a few of them. And we'll come back to this when we do some sort of example or talk more in depth about this part of it, but that is the reference guide. So let's do an example line of code, and I'm going to use the print function, which is a capital P, and you can see everything is good because it went blue, right? And then a function, like all function, needs curly brackets like that, and then we're going to define the end of line. So, but when we look inside these curly brackets, print either requires a variable name to print to the max script listener, or it requires a string. A string is enclosed in these inverted commas, and so we're going to type hello tyFlow script. So here I'm saying print a line of text that is hello tyFlow script to the max script listener, and that is a complete, accurate line of code, and I'm now going to evaluate it. And when we go up here to scripting and we open the scripting listener, and let's clear all this out. So we right click on this area and go clear out, right? And I've got my other operators in there, but let's go back here now and click evaluate. And you can see here that current frame is 0, and there's my hello tyFlow script, right? And then there's some, every time the script ends up completing for that whole frame, tyFlow by default inserts this extra line of information, which is information about the execution of a script, right? And what we care about is this line of text here, which is hello tyFlow. Now the reason we got this other information is because I have these other operators enabled. So let's disable this one, disable that one, go back. Now we only have this one running, and if we go back to our scripting listener and clear this out and then reevaluate that line of code, which is the same as executing it, right? So now you can see that the only information that came is what we typed here, this print function, and it typed hello tyFlow script. Now let's say I want to add another line, and then we're going to make an error, right? But we're going to, right now we're going to copy and we're going to paste. So Control C, Control V, and then we're just going to kind of add this little separator line, right? Which is just some dashes, something like that. And we'll re-execute, and everything is good. And now you can see that we've got this hello tyFlow script with these lines underneath, and there's our 2 lines of code, and we've technically executed our first tyFlow script. So that's not very exciting, because what the hell am I going to do with printing something to the tyFlow scripting listener? But believe me, you're going to use this print function a lot, because it's going to help you debug your code. You're going to send information to this tyFlow from this tyFlow coding section to the Mac script listener to understand that you've created your code properly. So now let's talk about this debugging section. First here it says script executed successfully. Well, what does that mean? It means that all my formatting in this code section of the script editor was formatted correctly and it was actually executable code. Let's say I purposely make an error in my print function here and I forget to put this inverted bracket at the beginning. That is an erroneous line of code now. And if I go in and evaluate, it's going to come up red. And it's going to try and tell you where it thinks the problem is. So if we look at this red section now, and we can see it says error, and it tries to indicate what line the error is at, right? So we go down here to roughly line 28. So, and then we have a close look and we go, oh, it's missing an inverted comma here. So we put that back in and then we come up here to see if we fixed our error and we re-evaluate and good. Yeah, everything is good. And that sent everything back out to this tyFlow scripting listener. So, yeah, that's the very basic kind of function of this part of the scripting editor. So let's take a quick look at this default code that's been inserted into a default script operator. So we'll zoom in on this section. Remember there's 2 lines of code down here that I created. And let's zoom in a bit. And let's talk a little bit about what this means. Earlier I told you that comments were these 2 forward slashes. But we can see by the coloring here, from this point down to this point, it's all colored the same and it's the color of a comment. Now remember, a comment is non-executable code. It's only there for information. Well, what's going on, Rob? You told us forward slash was a comment. Well, there's a second way to create comments. And that's by doing a forward slash followed by an asterisk. That's the beginning of a comment section. And asterisk followed by a forward slash is the end. So what this opening part here and this closing part of a long comment is a way that you can comment out a whole section of code, right? So rather than putting these forward slashes at the beginning of every single line from there to there, we can use this method to comment out code. So keep that in mind. Now, Tyson created this section of code to hopefully try to, help you understand how you might start to proceed writing tyFlow compatible code. Now, we haven't talked about loops, and I will, but this is a loop, which means that this loop is going to execute any number of times specified by what's up here, and it's going to execute everything that's between the opening and the closing brackets. And then we've already seen a line of code, so this is a full functioning line of code. We define a variable called simulation index. That's what Tyson likes to use to say the index of a particle, right? And it's going to be of type integer, which is whole numbers, and it's going to equal some information we get here, which is the tyFlow class and a function that's built into the tyFlow class that gets the simulation index of a particle and returns it and puts it in this variable. That's the basic kind of concept of a line of code and variables. We create a variable, it's going to hold some sort of value. We insert whatever the value is into that variable and then we use it at a later point. Right, so as this is looping through, this simulation index is going 0, 1, 2, 3 to whatever number of particles there are, right? And so now we're doing another line of code here where we're doing the variable type float, and float is a decimal number. So we're going to store a decimal number in a variable called event age, and we're using another tyFlow class function called getEventAge. And we're going to put that in this variable and then use it at a later point. So we're already getting complicated. If you're not a coder, this is already starting to get complicated. But what we probably should do is try to go through an example and where do we get all this information from? Like, where did TF get event age, for example, come from? Right? Where did this come from? How do I know how to do it this way and not another way? Well, I think at this point we try and do a simple example. So this tutorial is already coming up to 25 minutes-ish, and we haven't covered a lot except the basics, and we have to stop somewhere and do part B and C, etc. But let's at least finish with doing something. So let's close this zoomed in window and let's disable my drawing program for a minute and close this window here, and let's have a look at my Notepad+, which is where I've taken this API, which is the programming language guide for tyFlow script, and I've divided it into its different sections, right? So I'm using Notepad+ because it allows all these windows, and I've divided each one of these sections into its class. So what the hell is a class? Well, it gets complicated. It's kind of like a function, but more importantly, it's like a grouping of related variables, methods, and functions that are kind of gathered in one spot. If we go back to the shopping bag analogy, you can kind of think of it like that, right? So all related functions and methods have been gathered in a single shopping bag called a class, and in this case the class is the TF class. So all these things here are things that we can do from the TF class, and the best way is to do a quick example and then develop on that with parts B and C, etc. So this tyFlow class is one of the things we're going to access the most. And then if we go in here, we have the simulation properties, right? And so this is the tyFlow class, and we'll show how to access that in a minute. And then we have some more complicated topics like the tyFlow object and texture mapping and access to texture maps. And then we have some simple things we're going to use all the time, like these here. We have some miscellaneous functions, and you can see here this was how we printed out something to the MaxScript listener. And so by organizing it in Notepad+ to get all these into separate little windows, I can access the help information I need rather quickly. And what this information is telling me is how to use these variables, classes, and functions. It's trying to give you that information. Now, Tyson, in my mind, is a savant. He has to be doing as complex a thing as he's doing, which means he's probably not real good at breaking down things into simple terms for newbies, artists, or whatever to understand. So everything he writes and creates is very precise, extremely precise. And to some degree, because of who he is, and I'm not judging him, he probably doesn't give you much information because to him this is all fairly simple and straightforward. So you kind of get the basic information you need. Now we're going to try and somehow make this a more artist-friendly tutorial than, say, a coding-friendly. People who code mostly get this stuff. There's some real good coders who think this is nothing, but you know, probably most people in this kind of tyFlow 3ds Max world are artists and not necessarily coding minded. So having said all that, let's try and see how we access some of this information and we do something before this tutorial ends in code. Alright, so I'm going to drag this help out of the way and let's do something. So the first thing we're going to do is we have a box. Alright, I've created a box in the viewport and it is just we'll make it a 5, 5, 5, 5, 5 box centimeters. And you can see that when we look at our tyFlow information, I'm displaying the ID of the particle, and we can see here that the simulation index of the particle and its ID is 0. So because we're only going to use one particle and we only have one value and we're not going to delete it and we're not going to create more, we can directly use these IDs in our code, right? And here when we look at the top viewport, you can see clear ID 0, simulation index 0. So we go into our code, and for our first line of code we want to create or do something with this box. So let me turn off the actual object. So now we're looking at the tyFlow particle, and you can see all that's happened so far is we've created a box, and we'll turn off these other operators, and that's it. Nothing else is happening, and we got this default script operator. So now we're going to go into it. Now let's talk about these rollouts very briefly. They need more in-depth tutorial, but these are ways to give script access to particular objects in the scene. We don't need them for this example, and to get access to some texture maps. And this section out here called floats is a way that you can have these variables. So you can click one, you can say give it a name, and then you can either set a value or not. And these are a way to create input boxes that are accessible through code. And you might say, well, why would you do that? I already have code, right? Why would I want to do that? Well, one way would be that you create this counter or whatever out here, and instead of trying to control its value, say through code, you can animate this slider, right? So if I call this variable, I'm going to give it a name, and my way of doing that is the type. So it's going to be F because it's a float, and it's just going to be a vary number. So now I've called this variable F vary number, and right now its value would be 0, right? And we're not going to go in script here and access this at this point. I'm just showing the difference between doing this here and then doing it here. But when we come back, we will do an example of this. But I will show what the benefit is. So we're on frame 0, right? So now we go to frame 100 and we put on auto key. And here we put 100. Right, so now we see the red box indicating that this spinner has now been animated, and we can see that the value is going to change over time. Alright, so that is one benefit to doing variables out here, is you can do things with these spinners. And let's just see what that did for us in code. So we're going to turn off auto key. We're going to go into tyFlow and open the script editor, and we're going to delete all of the default code. We'll leave our print because we'll use it, we just alter it. So we're going to say begin. First code. And let's execute that and see if it's going to stay green. File, evaluate. Get used to executing or evaluating often to be sure your code is good. So now we need to go into the scripting listener and see what was put out on it, and we're going to clear it all so we can start by default and do evaluate and see. We get begin first code, the dotted line, so there's our 2 line of current code being executed and sent to the Max script listener, and this is tyFlow default information that gets sent every time, that gets sent out to the listener every time you execute some code. Right, so now let's actually access that variable here. So let's get into our API and find out how we access this variable called fVaryNumber, right? So we go in here, and because it's all bundled together, we kind of have to scroll through it and look for it, but I know it's in this section called Miss Functions, and these functions can be accessed directly. So we can see here that we have 2 methods of accessing those spinner values, right? One will get the value, but it'll only get it at frame 0. The other will get the value, but it'll get it at whatever frame you specify, right? So let's take this and copy this into our editor. Copy. And we go into our editor below these print lines that we already created, and we click paste. So dissecting this line, we got a function which is a grouping of code. It can return something, and it can get us information that we need, or process information, or process code, right? In this case, it's going to get the float value from this variable. So first thing, it needs a float. So we're going to say float, which is defining a decimal number variable holder, and we're going to call it float number holder, and we're going to finish it with the semicolon to define a line of code. So now we've created a variable which is going to hold the information we're going to get from this getFloat function. So now we can start to do this, right? We can say f number holder equals getFloat, which is the function up there, and we'll put the end of the line in. So getFloat requires 2 parameters. It requires the string name of this box, and it requires a frame at which to get the value from this box. So our string name, remember strings need to be in inverted commas, so there's our double inverted commas, and it's the name that we got up here exactly, right? So fVaryNumber, and then a comma separates 2 required values. So the comma separates those. So the second parameter is a float of type frame number, right? Well, tyFlow has a built-in variable for that, which is the f, and we can just use that directly. So now this line of code should be complete. Let's delete this because we only used it as a reference, and let's go in and evaluate, and hopefully we get a green screen, which we did, which means we have 4 valid lines of code with no error, and we can execute that, but we're not going to see anything in the script listener because we haven't created anything to put out there except our 2 lines of code, right? So if I click evaluate, and all we're going to see is this. We're not actually going to see if we're getting the very number, right? So one way that we could handle that is we could create another print line for debugging purposes. So if we copy this, Control C, Control V, and now instead of printing these dashes, we're going to print this variable. So variable does not need to be in inverted commas, that is only text. So we type FNUMBER holder. So now this third line of code here is saying that every frame print this F number holder value to the max script listener. Let's evaluate. And let's see what it shows us. Oh, it shows us 0. Now, if we try to separate all these windows apart so we can see all of them at once, right? And I'll put that there, and I'll put this over here, and we put this down here somewhere, and I execute the timeline. Alright, you can see, whoa, what the hell? We got all these numbers. What happened? Well, that's got to do with time step. I told you this wasn't going to be an easy lesson. Alright, so we come over here and we can see that it's currently set to 1/4. So we just learnt something seriously important and seriously new. The code gets evaluated every time step unless we do something to prevent that, right? Maybe we don't want our code to run, 4 times a frame or 8 times a frame, because that's going to change everything if it's being executed more than what we want. But that's a complex subject for the next lesson. So for now, what we're going to just do is go back to do it per frame. We're going to clear, put this back on 0, and we're going to clear all. And now, because we're on time step frame, the code should only execute once per frame, which is what we want for this lesson, right? So if I close this window for a minute and I step through, I clear this, and we go forward 1 frame, you can see that the value being shown here is 0.29779, and you can see up here it's showing 3. And then we do the next frame, and you can see it's doing 0.1184, and up here it's close enough. It's just within the error of the decimal placings, right? And if we kept scrolling through the timeline and we went all the way to the end, we've now printed out 100 lines to the max script listener with the value of this spinner being printed out. All of them are there, right? So that's really our first bit of functional code. So let's not finish with just that, but that is the benefit of having these outside rollouts here, is you can do stuff where you keyframe values, right? And that's going to be more intuitive to artists, whereas coding people might just have done this in code, right? Artists are more likely to use this kind of thing to control their objects. So we've learnt how to access these rollouts. We've learnt where to get the information to understand how we get there. And we've done a couple of different lines of code. Let's finish on a simple thing where we just scale up the box. Let's scale up the box. So I'm going to clear this history. We're going to close the max script for listener for a bit. We're going to go back into our code, and right now we're going to comment out these 3 lines of code because we've seen what they do. And so there's 2 ways we can comment them out. That way, which is the long way. You've got to do it for every line. So now we've invalidated those 3 lines of code, and they're now just comments, which is non-runnable code. We delete that. The second way is to do the / followed by the asterisk, and you can see that everything below that went this color, and we've actually invalidated all sorts of stuff That's because it expects the opposite to define the end of that. So we go asterisk /. You can see that these built-in tyFlow functions went back to their normal coloring, but we've grouped out this block of code. We've commented it out. We've just made it inactive. Now we're not going to talk about simulation step threaded, and we're not going to talk about post simulation step or simulation start, because we're just going to concentrate at this early stage on performing some code every frame. So to finish off this beginning intro, let's scale the box up, right? So we know that this is particle 0, and we know there's only one particle, so we can directly access it using its ID. But how would we scale this particle? Well, we have to go back into our API, and if we go into the API here and we scroll down into the TF class functions, right, the tyFlow class functions, and we scroll through here, eventually we get something that either says get scale, or we go further down and we get something that says set scale, and right now I can't find it. There it is, right? So this is how we would scale a particle. So let's copy that part of code, close that, and come in here right now to paste. Alright, so set scale doesn't have a return, so we don't need a return, but it requires the particle ID and the scale amount in this format of 0.3. I mean, wow, are we just digging a bigger hole or not? Like, what is 0.3? Well, let's just get to the point where we scale this thing, and in parts B and C we'll get more into it, but we will know in this lesson how we get to this 0.3 and work out what it is. So the first thing is there's no return type, so we don't need any variable to hold a return value. So we can just use the set scale function, right? And that's the function, and we'll define the end of the line. So I'm going to comment out this line for a minute, and we're going to execute or evaluate. And it's going to tell me that there's a whole heap of errors, right? First of all, it says set scale function doesn't exist in the current context. This is how you're going to debug and troubleshoot your code. But I'm going to go into my notepad. You can go into the API, and we go in here to the tyFlow class functions. So the first thing you need to see is that this is tyFlow class. So this is a class. So this get scale or set scale is, and I've sorted them here, right, is part of a class. So when we go over here to simulation properties, we can see that TF is actually the class, right? So just trust me on this, that anything in these tyFlow class functions here, right, these tyFlow class properties, they're going to have to be preceded with TF dot, right? So for this to be a proper access, we have to type TF dot set scale, and what that is telling us is we're accessing the TF class, and we're accessing a function called set scale inside of that TF class. Now if we reevaluate, we're just going to get another error, because what this overload means is that there's no proper format. You see, the set scale requires the index, and it requires a 0.3 value on what we want to scale. So the index is easy. Now I'm going to type the value directly because we only have one particle. So our particle is 0, right? So that's the first part of the parameter requirement met. But what is this 0.3 value? Well, what does that mean? Where do we get it from? Alright, so we go back in, and you go into the API. I'm just going to go straight to where I've sorted it out and separated it. So this is still in the API. It's just you have to dig through to find it down here, right? We'll close that. We go back to my Notepad+, and we can see here that .3 class has 3 members, which is the X, Y, and Z values, right? Alright, so let's try and create one. So we're going to need a .3 variable, P-O-I-N-T 3, and we can see it's typed correct because it went the nice color. And we're going to call it P3 value, or scale value. We'll call it, let's be more specific, scale value. Alright, so now we've defined a .3 variable called P3 scale value. And we're going to use that to access this function and scale our box, right? So it requires an X, Y, or Z, right? And when we went back in here to our help, you can see that there was an X, Y, and Z. Now, maybe I can have another lesson on this, but I'll just show you how to access this. So we have our variable P3 scale value. That's our variable. And we want to access the X, so we did .x, and we can see it turn blue. And at this point, we're just going to scale it 2 times. Right, so now we've accessed the X part of the scaling. Now, if we executed that, it should technically work. So we need to put this P3 scale value in here, and we evaluate and see if we get green. Alright, so I created this error on purpose, right? The P3 variable type requires 3 parameters, and we haven't assigned anything to the other 2, the Y and the Z, right? So it's telling us that we have some unassigned variables, and that can't fly. It needs to be complete, right? So in this instance, let's copy these 2, this line of code, Control C, Control V, Control V, and we're going to change this to X, Y, and Z, because that's the 3 values of a .3 system. And we're not going to scale in the Y, so we're just going to make it 1. And we're not going to scale in the Z any different. So what we're saying right now is we want to scale this box 2 times in the X direction. So now we've met all the requirements of this tyFlow class function, right? And now we're going to evaluate and see if we fixed our code. And you can see we got a green box and something happened here. And I'm just going to go back to frame 1 here, and we'll reevaluate. So at this point, we probably have to stop this first introductory class on scripting, but at least we've performed a couple of actual coding examples, and there's a lot more complex topics and things to go through. You've seen how to debug a little bit, you've seen what different variables mean, and you've seen how to find out how you format your code to meet the requirements, right? Now, if we just add one more little bit to our code here, if we come up here and go copy, this is our print functions, and we put them underneath here after we've scaled. Control V, right? And then we come down here and we change this to say scale in the X, right? So I want to know on screen what my X was. So scale in X. And then we come down here, and now we want to print that to the Mac script listener for debugging purposes. So we could actually take this variable here, copy it, and paste in our print function, and go to the Mac script listener, right? So Mac script listener, we clear everything out, clear all. We put it on frame 0, clear all, and we do an evaluate. And let's see what shows. So you can see here we got our 2 lines that we said print here. That's our 2 lines there. You can see this new debugging information that we just created is here. So scale in the X, and it's at 2. So we'll close out this tutorial with this debugging method. We'll come back in another lesson for some more complex topics, but I hope that was a good beginner intro to scripting in tyFlow.